welcome to Under 5 Minute series. In this series, what we'll do is we'll try to learn a concept in less than 5 minutes. So, without wasting time, let's start with our today's concept, which will be thermoelectric effect. Now, what you can see here is the three terms Seebeck effect, Peltier effect, and Thomson effect. Now, all these three are collectively known as thermoelectric effect. In this video, what I'll try to do is simplify them for you. So let's start with Seebeck effect first. In 1821, Thomas Seebeck discovered that if two different metals are connected at their free end to form a loop, and one of the two connection points is heated, a nearby compass would deflect. Now, this was initially thought to be a thermomagnetic effect. Later, it was found that a voltage was induced in the loop, now which induced current, and then by Ampere's law induced a magnetic field. Well, that's too complex, I guess. So, let me simplify that for you. Now, let's talk about thermocouples first. So what are thermocouples in simpler terms is when we take two dissimilar conductors and then we join them by their two ends. That is thermocouple for you. Now these ends where they are joined are popularly known as junctions. So what Seebeck effect says is if the two junctions of a thermocouple are placed at different temperatures, then because of this temperature gradient, an EMF will be produced in the thermocouple. And this EMF will be proportional to the temperature difference. So what you can see in the figure is I have two junctions, 1 and 2, and both are maintained at different temperatures. One is hot, one other is cold, and there are two different metals, and there's a temperature difference because of which a potential difference is created, which is proportional to the temperature difference. Now that's Seebeck effect for you. Now let's move to Peltier effect. Well, I won't read the slides in this case. So if you want to further refer this, what you can do is I have highlighted few points, the bold ones. You can go through them if you want. So what I'll do is I'll try to explain Peltier effect in a very simple manner. Now what Peltier effect is it is just the reverse of Seebeck effect. Now what Seebeck said was in Seebeck effect what we're trying to do is now there's a temperature difference and that temperature difference is leading to potential difference. Now Peltier effect is just the opposite of this. Means a potential difference is leading to create a temperature difference. So if two dissimilar metals or two ends of thermocouple are maintained are connected, and then what we do is we pass the electric current through it, because of this potential difference the two ends will have a temperature gradient between them. Now that is what Peltier effect for you, just the opposite of Seebeck effect. Now let's move to the third one, which is Thomson effect. Now this work of Peltier and Seebeck, actually Seebeck invented the thermoelectric effect. Further work was done by Peltier, and then their work was carried out by William Thomson. Now you know William Thomson very well, but by some other name. That name is Lord Kelvin. Yeah, Lord Kelvin gave this Thomson effect. He has this contribution in thermoelectric effect also. So what he said was if an electric current is passed through a metal and that metal has varying temperature along the length of a bar, then due to this temperature difference or actually temperature gradient along the length of a wire, there will be a development of voltage in the wire. So that's Thomson effect for you. Now I have summarized their work in this slide. So summarizing this presentation, if I want to say now Seebeck and Peltier effects are nothing but reciprocal of each other, and they occur between two different materials. Whereas Thomson effect, if you want to understand in one single line, it is Seebeck effect for a single material. Note, Thomson effect, we are considering only one metal. Along a metal, if there is a temperature gradient that is leading to development of a voltage, that is Thomson effect for you. Happy learning, guys.